It's time for STEM with COG. When I got my driver's license, I felt like I'd been handed the keys to the world. I was free. Back then, I thought gasoline came from, gas pumps. I never questioned what happened to the gasoline in my tank. I didn't know that CO2 comes from burning fuels that are made from crude oil. I had heard rumors that gasoline was made out of dinosaurs. That was wrong. Turns out crude oil is mostly made out of plankton that lived in ancient, warm, shallow seas. The crazy world of plankton includes phytoplankton, minute organisms that can photosynthesize, and zooplankton that eat other organisms. Plankton die, like Sheldon's 10 trillionth great-grandparent did about 300 million years ago. Dead plankton fall to the ocean floor where they're buried in more dead plankton and mud from rivers. Let's call that plankton goo. Water and layers of dirt apply pressure that pushes the goo deeper into the earth where heat causes chemical changes, turning goo into crude oil and natural gas that fills the empty spaces between the grains of sedimentary rock. The oil and gas can travel upwards through the spaces until they hit an impermeable layer of rock. Bam! No more travel. Reservoirs form. We pump crude oil up from those underground reservoirs. Now it looks like this, a mix of lots of different hydrocarbons, molecules made of carbon and hydrogen. We have to sort them so we can use them. Imagine you ran out of gas, COG, and all you had was this barrel of crude oil and some sorting boxes for the hydrocarbons. You better start sorting, COG. I see you've picked up C3H8. That's propane. Which box does it belong in? Not fuel oil, not wax, not diesel, not jet fuel. Maybe it's... No. Hey, it stays in the box for light gases. Okay, try something bigger. You picked C12H26. What's that? Not fuel oil, not wax, not diesel. Hey, it's jet fuel. Smart move, COG. This time you picked C8H18, a hydrocarbon with more than 3 carbons and less than 12. Let's see if it works. Yay! Now you can fill her up, and away you go. If only that worked in real life. Hey, wait, it kind of does. We do sort hydrocarbons at oil refineries. First, they heat the crude to about 400 degrees Celsius or 750 Fahrenheit. Now all the molecules are in a gas phase. To sort them out, we use condensation, when a gas becomes a liquid. Remember how water goes from liquid to gas or from gas to liquid at 100 degrees Celsius or 212 Fahrenheit? These hydrocarbon gases, they condense at different temperatures. That mix of hydrocarbon gases goes into a distillation tower where temperatures range from hot at the bottom to about room temperature at the top. Lighter hydrocarbons have fewer carbons and condense higher up. Heavier hydrocarbons have more carbons and condense at the bottom. Once they're all sorted out, we can use the parts to make electricity or plastics or other materials. Stop the video if you want to take a closer look, but I'm going to focus on fuels. We burn a lot of gasoline in cars. How does a fire in our engine spin our wheels? Well, let's start with a combustion chamber in an internal combustion engine. To make a little fire in there, we need fuel, gasoline or diesel, and oxygen in the air, and heat. Step 1. Oxygen mixes with gasoline droplets. Step 2. The piston moves up and compresses the air-gasoline mixture. That'll make it hot. Step 3. Bang! Diesel engines get enough heat from compressing the air, but gasoline engines need a spark to combust. Either way, you get a chemical change that produces carbon dioxide, water, heat, and light. Those heated gases expand, pushing the piston down. Step 4. The piston rises to push out the exhaust, Mostly just invisible CO2 and water if your car is tuned up. Here's what happened. C8H18, that's one form of gasoline, plus 12.5 O2s, plus heat, produces 8 carbon dioxides, 9 waters, and heat and light. As the pistons go up and down, they turn the crankshaft, which works a bit like this hand drill. The drill bit is like the drive shaft. It's spinning now, but not in the direction our wheels spin. Ring gears, like the ones in this egg beater, will fix that. Now the spin moves the tires forward. For this rear-wheel drive car, you could say, the piston's connected to the crankshaft, and the crankshaft's connected to the drive shaft. The drive shaft's connected to the ring gears that spin the wheels of the car. Them wheels gonna spin around. Them wheels gonna... Well, you get the idea. Very simply, jet engines work a bit like this balloon. As the pressurized, powerful gas moves out the back, the balloon is thrust in the opposite direction. Here's a way to visualize thrust from expanding gases. First, I'll put on safety goggles or glasses and move outdoors into a clear space with no bystanders. I drop a half an Alka Seltzer tablet into this film canister half filled with water, snap on the cover, and, this is important, flip it upside down. The water dissolves the tablet so the bicarbonate and citric acid can react to produce CO2 and water. Air pressure inside the canister builds and builds until pop! The gas is pushed down, thrusting the canister up. Let's watch in slow-mo. Gas pressure is really powerful. It moves heavy planes full of people and things through thin air. Real jet engines go through the same 4 steps as your car engine. Cool air comes in, it's compressed, which heats it up. When fuel is injected, it combusts. Exhaust shoots out the back, thrusting the plane forward. In 2021, we produced 7.6 billion tons of carbon dioxide by transporting people and things around the globe. That's a lot of ancient carbon we added to our atmosphere. I explained in previous episodes that 1 ton of carbon dioxide would fill a beach ball about 10 meters or 32 feet high. Imagine 6.7 billion 1-ton beach balls. They'd circle the Earth about 1,900 times. About 30% of that extra CO2 gets absorbed by oceans. Plants and soil combined absorb less than that. The rest of it stays up there for over 100 years, mixing with the CO2 from last year and the year before that and the year before that and the year. They're all up there bouncing heat around as greenhouse gases do. Let's recap. Hydrocarbon fuel comes from crude oil that is refined. It mixes with oxygen, is compressed, and combusts, causing a chemical reaction that produces CO2, water, heat, and light. Pressurized gases move heavy things like cars and planes. Globally, in 2021, we produced 7.6 billion tons of excess CO2 made from ancient buried carbon to transport people and things around. It's weird to think that so much of the CO2 from my first driving lesson is still up in the atmosphere. And speaking of gas, let's get natural and talk about